So today I've been tasked with fine-tuning a large language model. And in particular, I want to try and fine-tune the Llama 70B model, which is obviously quite a resource-intensive model. And so I'm going to show you how we can do that within the Domino platform. I've already configured the code and the data for this particular project. In this case, we're going to actually be using a Ray reference project, and I'll talk to you a little bit about why in a moment. The first thing I'm going to want to look at is the workspace or the interactive development environment that I'm going to use to start this job. So I've got one set up here, and if we have a look at the settings, I can talk to you why it's configured this way. So firstly, I can choose the IDE that I want to use. And secondly, I can choose the hardware that I want to use. Now, in this particular instance of Domino, I've got several different types of hardware available to me, a couple of different types of GPU nodes with single GPUs. I could also leverage some of these larger 8 GPU machines as well. But even with those 8 GPU machines, it's not going to be sufficient for training, for fine-tuning the Llama 70B model within a reasonable amount of time. So a single machine is not really going to be sufficient for me. So instead, what I'm going to leverage is Domino's native support for distributed compute frameworks. In this particular case, I'm going to use Ray. So here we can see my settings for my Ray cluster. I've chosen to have a Ray cluster of 32 node size. So I have my head and then 31 worker nodes. Obviously, I could change the scale of this based on the hardware that I have. Maybe I would be using multiple of those 8 GPU machines. In this case, I'm going to be using 32 of those single GPU machines. And interestingly, from an end user perspective, I don't need to understand the specifics of the hardware or the topology there. Domino is going to take care of the complexity of that for me. So these single core machines may actually be slices of a larger physical piece of hardware. So it could be that several of these GPUs sit within the same node. But Domino is going to manage all of that complexity for me. I've also set up some dedicated storage for each of these worker nodes because I know that I'm going to need a fair amount of storage for saving things like temporary files. So I can click Save and Restart, and this is going to start that workspace for me. So it's going to assign some nodes based on the pool that it has. If I'm running within the clouds, this may be using auto scaling to provision those resources for me. It's going to mount the specific storage volumes that I've asked for. Domino is a containerized platform, and so it's going to be pulling the container images both for the interactive development environment and for the Ray cluster as well. And then it's going to be pulling in my files and taking me through to that development machine. While that's loading, what I'll do is I'll show you the container side of things here. So if I go back to the main Domino UI, you can see that when I configured this, I chose something called a compute environment, one for my IDE, my interactive development environment, and another for the Ray cluster. So let's have a quick look at those. So within Domino, I can have a number of different environments. Each of them can be configured by the data scientists themselves to be tailored such that they're set up for the specific libraries that I'm going to need here. So if I take a look at the Ray cluster image, for example, we can see how this is set up. Firstly, I'm importing actually the Ray image from any scale. So in this particular case, I'm using Ray 2.7.0. And on top of that, I've laid down a few different configurations that I need. So I'm installing a few of the different libraries that I'm going to be using. So Deep Speed, for example. And then installing things like bits and bytes and configuring those. setting the appropriate CUDA version as well, and making sure that certain volumes on the environment are going to be accessible to the processes. So again, as a data scientist, this gives me fantastic flexibility to come in and tailor these images with the libraries that I need for my particular training exercise. So it looks like we're still waiting for a node to start up. Now we're moving into the volume mounting phase. So this will take a few minutes depending on the availability of the hardware within your particular environment. Similarly, the size of the containers. But once we're up and running, we should have our cluster associated with this particular workspace, so we can get started on running that larger model. Okay, so now that I'm into the workspace, we can see that I've got my reference project code here, and we can also see that I have my Ray cluster attached to this particular workload. So we can see that I've got my 32 nodes with their respective GPUs. So now I need to actually kind of run the code that I want to execute. So let's take a look at what that's going to be. So if I navigate through to the Ray example, in this case, the fine tuning with deep speed, and there's a README in here which is going to walk me through how to actually execute this particular piece of code. So what I want to do is pull up the terminal in this case and run this Llama fine tuning script. So first of all, navigate to the correct folder. And we can see here the file that I want to execute. So what I'm going to do is I'm going to pull in the specific execution here, and that is to run the Llama fine tuning. In this case, I want to use the 70B model. And just to check that everything's working correctly, I'm going to use this as test parameter, which means that it's just going to run through a single epoch. And so I can execute that here. And so what this is going to do is it's going to check that I have the right data in place. It's going to see here, understands the topology of the Ray cluster. It's going to go through based on my training config that I've pre-configured, and it's going to push those different training jobs out to my 32 node Ray cluster. So if I go across into the Ray web UI now, we'll be able to see that each of these will start to do some CPU load work to start with, as the various different training configs and files are propagated across. What it's going to do now is it's going to pull all the base weights in. So this will take a few moments, and then it will start to pull in the checkpoints and actually run the fine tuning. So as the training starts to kick in, we can go over to the Ray web UI, and we can see that we're saturating these GPUs. So again, 32 of these running. Now, the Llama model is going to take quite a long time, even just for a single epoch, even with this number of GPUs. So I'm not going to wait for it to finish within this video, but hopefully that was useful to show you how you can leverage multiple GPUs across multiple nodes using a Ray cluster in Domino.